All right, welcome to this explainer. Today, we're taking Azure's somewhat dense cloud architecture and storage specs and, well, we're turning them into a clear visual blueprint. If you've ever looked at the sheer volume of cloud services out there and felt a little overwhelmed, don't worry, you're in the exact right place. We're going to take a really structured, step-by-step approach to understand exactly how Azure handles and, more importantly, protects your data. So, think about it. How do you actually store and protect your most critical enterprise data in the cloud? Let's dive in by imagining your enterprise data not just as abstract bytes floating around in the ether, but as highly valuable physical assets. When you have priceless items, you don't just leave them out on a table, right? You need two things: a highly structured vault to keep everything organized and safe from disasters, and an impenetrable fortress surrounding it to keep the bad actors out.
To make sense of all this, here's our quick blueprint for today. 1. The Azure Data Vault. 2. Tiers and redundancy. 3. Identity as the perimeter. And 4. The Zero Trust Fortress. Let's get right into it.
The Azure Data Vault.
Every single piece of data needs a home. And in Azure, that whole process kicks off with a storage account. You can think of this as the main entrance to your specific section of the vault. Now, because this is a massive cloud environment we're talking about, this account has to have a globally unique name. It acts as this overarching container that dictates which specific storage services you're going to use, how your data gets accessed over the internet, and your baseline redundancies. Basically, you can't put a single byte into the vault until this container is set up.
Once you're inside this account, you've got to pick your storage type based on what you actually need. Take Azure Blob, for instance. That's your massive, unstructured repository. It's perfectly optimized for text or binary data, so things like images, documents, or streaming video. Then you've got Azure Disk, which provides the dedicated virtual hard drives that your virtual machines and apps desperately need. I mean, you wouldn't use a disk to stream a movie to millions of users, and you definitely wouldn't use Blob to boot up a Windows OS. Building on that, what if you need a highly available network file share, maybe for some legacy apps or traditional Office setup? For that, you'd grab Azure Files, which uses the standard SMB protocol. On the flip side, if you've got structured data but really don't need the heavy lifting of a full-blown SQL database, Azure Tables is your go-to. It offers this brilliantly fast, schemaless design that's perfect for non-relational key and attribute data.
64. Here is a totally fascinating constraint for you. If you're dealing with application messaging, you'll want to use Azure Queue. This service is purpose-built to handle absolutely massive amounts of messages passing back and forth between different parts of your apps. But here's the kicker. Each individual message is strictly capped at just 64 kilobytes. It is built entirely for volume and speed, not size.
Now check out the pattern in these public endpoint URLs. It's incredibly elegant. Your globally unique storage account name just slaps right onto the front, followed by the specific service like blob or table, and then core.windows.net. This naming convention makes over-the-internet access worldwide so organized and predictably easy for your applications to connect to.
Moving right along to Section 2, Tiers and Redundancy. So, our vault is built. But what happens to the data inside if an entire data center just loses power?
Well, Azure gives us this awesome sliding scale of protection. It starts at locally redundant storage, or LRS, which keeps copies inside a single data center, and climbs all the way up to Geo-Zone Redundant Storage, or GZRS. Look at the durability column there. LRS alone gives you 11 nines of durability, which is already wild. But as you spread that data out across multiple availability zones and even entire secondary geographic regions, that durability just skyrockets.
16. That's the magic number here. By mirroring your data across 3 separate availability zones in a primary region, and then combining that with a single data center in a completely different secondary region, GZRS achieves an absurd 16 nines of durability. That's 99.999, well, you get the idea. At that level, your data will probably outlast the physical building it's stored in. It practically guarantees survival through almost any conceivable regional catastrophe.
But look, keeping all that highly redundant data spinning on a dime, that gets expensive fast. So beyond redundancy, you have to optimize costs by tiering your data. Think of the hot tier like the active papers right on top of your desk. You need them immediately and constantly. The cool and cold tiers are for files you check way less often, requiring a commitment of 30 or 90 days. And then the archive tier? That's like an off-site deep storage bunker. It's incredibly cost-effective, but your data has to stay put for at least 180 days. And getting it back has flexible latency, meaning it definitely won't be instantaneous.
All right, so our data is perfectly categorized, it's cost-optimized into tiers, and it's redundantly backed up to survive a literal disaster. The vault is complete. But a vault is totally useless if you just leave the front door wide open, right? It's time to shift gears and build the fortress around it to keep unauthorized users out.
Which brings us to Section 3, Identity as the Perimeter. In the modern cloud, we really have to rethink security from the ground up. The old corporate firewall, that traditional moat around the castle, it just doesn't cut it anymore, because people are accessing data from everywhere. Today, identity itself is the new security perimeter, and Azure uses Microsoft Entra ID as the bouncer at the door of your fortress. We're talking advanced authentication here, single sign-on, multi-factor authentication, and even totally passwordless access. And once someone is actually inside, strict role-based access control, or RBAC, ensures they can only see and touch exactly what they need for their specific job, nothing more.
And that leads us perfectly into Section 4, the Zero Trust Fortress. This heavy reliance on strictly verifying identity brings us to a massive philosophical shift in our architecture. We're no longer just building thick walls, we're building a system that inherently doubts everything. That philosophy is called Zero Trust. It literally means exactly what it says: never trust, always verify. It used to be that if you were plugged into the office network, you were trusted. Not anymore. Whether a user is hitting the vault from a public coffee shop Wi-Fi or a hardwired desk in the head office, this system assumes breach. Every single request is thoroughly verified. To actually enforce this zero trust environment, Azure applies a defense in-depth model using Microsoft Defender for Cloud. This isn't just one single security gate, it's a series of overlapping defense mechanisms. Defender is constantly analyzing systems for attacks, blocking malware, and giving you proactive security recommendations. It even does this super cool thing called just-in-time access for network ports. Basically, a port to a vital server is kept totally locked down, and it only opens up exactly when an authorized user needs it, slamming shut immediately after.
When you take the time to really master these Microsoft Learn principles, you aren't just memorizing a bunch of specs. You're learning the true blueprint of modern cloud engineering. You are architecting a highly durable tiered storage solution, and you're wrapping it in a ridiculously intelligent, continuously verifying security layer. So, as you prepare for your Azure journey or study for those certifications, I want to leave you with this final question to ask yourself whenever you look at a system. Is your data just sitting out there in storage, or is it truly secured inside a zero-trust fortress? Keep exploring how these tools are fundamentally changing the way we protect information. Thanks so much for hanging out with me for this explainer, and keep learning.